Okay, let's give you guys some more practice. So somehow come up with a Cartesian equation from these two parametric equations. T being from -1 to +1. Draw the graph and also the direction of the path as well. Okay, so press pause and have a go. Okay, so to do this, start from here. Rearrange this to make T the subject, and then here do the same. Make T the subject, and then later on we can set this to be the same as this. Okay, so the first step is to make this to be and this to make T to be the subject. So the first step, make T the subject. It will then give us this. Hang on. It will then give us this, and then going back here, make T the subject here. That will then give us this. That will then give us this. Okay, so now we can set this to be the same as this. So that will then take us to here, and then tidy this thing up, tidy up, and then y will be this, and then y would be this. So now it's just a matter of drawing this graph. What would this graph look like? Well, looking at this whole fraction breaks down when this bubble here equals 0. When will this bubble equal 0? It will be, this thing here will equal 0 when x is a half. So if you try and put a half into here, the whole thing will break down. So something weird happens dead on a half. So we would select a point just to the right. A point just to the right would be, let's just say 5.000001. Put this number into here. So that would then become 1.4999999 whatever, and then put this into here. This number here will be slightly bigger than 1. Slightly bigger than 1, take away 1, then it's going to be a very tiny number, 0.00000 whatever. So you've got this, you've got a definite number divided by a very, very small number, making the whole answer very, very big. So when x is slightly above a half, y would be very, very big. In fact, y will be up there somewhere. Let's just say it's around here. Use the same argument for this. Use the same argument for so select a point just to the left of a half. Let's say 0.49999 whatever. Put this into here and use the same argument, and it will make y to be negative very, very big, which will be somewhere down here somewhere. So let's just say it's around here. So just to the right, y would be very, very big. Just to the left, y would be very, very big, but negatively big, somewhere down there somewhere. So let's just say it's here and here. Now we need to investigate what happens when x gets very, very positive big, and what happens when x gets very, very negative big. Okay, so the trick that we would use is to visualize this as being one bubble and one bubble. Divide top and bottom by x. So this thing here will be 2 divided by x, and then you've got your takeaway x divided by x. So we are trying to investigate what happens when x gets very, very positive big. So divide, that's this divide here, and then you've got remember we're dividing top and bottom by x, so that will be this over x, and then you've got minus 1 over x. Now as x gets very, very big, this thing here will be 0. As x gets very, very big, this thing here will be 1, x over x, and then x over x, the two x's will cancel out, leaving you with 2. And then as x gets very, very big, this thing here will be 0, take away 0, and then here you've got negative 1, take away 2. So that will be negative a half. So as x gets very, very big, then the limit will be, as x heads towards infinity, the limit will be negative a half. So it will look something like this being negative a half. Okay, and then use the same argument for x tending to negative infinity, and it will give you something like this, x also negative a half. So your graph looks like this, but the thing is you have no idea from this you have no idea which direction and what strand is on. Is the particle going in this strand or in this strand? All that you know is that the graph looks something like this. That's all that you know. To find out the path and the direction of the path, we would revert back to the original parametric equations. From this, then you can work out what happens. So let's select a point just to the just to the right of -1, because we can't have this is greater than, so we can't have that on -1. So let's select negative 0.999999. Put that into here. So that will be negative 0.99999 over. Now put this into here. So that's negative 1.9. So you can see that this is going to be these two will cancel out, giving you well, this thing here is going to be near half. So we know that when we know the starting position, the x value will be near a half. So it's going to start somewhere around here. So it could be here, or it could be up here. So we know it's going to be around a half somewhere. So it's going to be, so remember our graph looks like this. We know when time equals near -1, it's going to be around a half. So it could be here, or it could be here. So and then now what happens when x gets very, very big? So what happens when time is well, what happens when now let's select time to be 0.9999. So let's put this into here. So that will be 0.999999, and then put this into here. And then you've got very, very close to 1. Take away this thing here will then be negative very, very small. Negative very, very small. So here this thing here will be very, very big, but then you've got a negative here. So it will be very, very negatively big. So when t is around here, x will be very, very negatively big. So x would be very, very negatively big, meaning negative big, meaning in this direction. So it must mean that earlier we knew that it would start somewhere near half, and then when t is near here, x would be very, very big, negatively big. So we know that the particle must be going in this direction. Okay.